Good morning to one and all. Today we are going to discuss about the engineering physics PH 8151 unit 3 thermal physics part B questions. Unit 3 thermal physics. The following topics are there: transfer of heat energy, thermal expansion of solid and liquids, expansion joints, bimetallic strips, thermal conduction, convection and radiation, heat conduction in solids, thermal conductivity, Farby's and least disk method, theory and experiment, conduction through compound media, series and parallel, thermal application, heat exchanger, oven. So these are the topics is there. Expression for thermal conductivity. Consider a slab of material of length x and area of cross section A. One end of the slab is maintained at a high temperature, that value is theta 1, and other end of the slab is having the low temperature, the value is theta 2. Now the heat flows from the hot end to cooled end. So that time the total amount of heat conducted from one end to other end value is capital Q. From this experiment, the amount of heat capital Q is directly proportional to the area of cross section capital A. The Q is directly proportional to temperature difference between the two ends theta 1 minus theta 2. The Q is directly proportional to the time of conduction small t. The amount of heat Q is inversely proportional to the length of the slab small x. So all the statement we can write in a equation format. So the Q is directly proportional to A, Q is directly proportional to theta 1 minus theta 2, Q is directly proportional to small t, and Q is directly proportional to 1 by x. That one we can tell Q is inversely proportional to x. So combining these four equations together, we can write the single equation Q is directly proportional to A into theta 1 minus theta 2 into T divided by X. So if you want to remove the proportional, we must add the constant. So here also they add the constant value. So Q is equal to Ka into theta 1 minus theta 2 into T divided by X. So here K is a constant, that name is a proportionality constant, otherwise it is also known as a coefficient of thermal conductivity. So its the value depends on the nature of the materials. The before equation is equal to Q is equal to, but now the equation we are changing, K is equal to Qx divided by A into theta 1 minus theta 2 into T. So the before last equation just we changed based upon the K value. So this final equation we are going to consider all the unit consider as a one unit except K and Q. So A is equal to 1 meter square, theta 1 minus theta 2 is equal to 1 Kelvin, X is equal to 1 meter and T is equal to 1 second. Then all the value if you substitute in this equation, then we can get the value K is equal to Q. So finally we conclude this expression for thermal conductivity. So this K is equal to Q, this condition defines the coefficient of thermal conductivity. So thank you. This is least disk method. Under this topic, two subdivision is there. One is a theoretical explanation, another one is a experimental explanation. So now we can see the theoretical explanation first. So introduction part, the thermal conductivity of the bad conductor like glass, ebonite or cardboard is determined with the help of the least disk method. So this is the diagram. In this diagram we can see the stand with a clamp, the clamp having that wire, steel wire, that steel wire holding the three parts. One is a steam chamber A and least disk, and another in between gap of the steam chamber and least disk bad conductor is there. The steam chamber is having the three holes, two holes for this passing the steam in, out and out, another hole for the keeping the thermometer, and least disk also having the one hole to place inside that thermometer, another thermometer. The given bad conductor is taken in the form of disc capital D. This bad conductor has the same diameter as that of the slab and it is placed on the slab. A cylindrical hollow steam chamber capital A having the same diameter as that of the slab is placed on the bad conductor. There are holes in the steam chamber and the slab into with the thermometer 1 and a thermometer 2 are inserted to record the respective temperature. Explanation part. The apparatus consists of a circular metal disc or slab of the radius small r and thickness h suspended by the string from a stand. Working of the least disc method. The steam is passed into the steam chamber until the temperatures in the chamber and the slab are steady temperature. So the readings theta 1 and theta 2 are noted. So the radius r and the thickness small d of the disc are also measured. So here the temperature it will come under on some steady temperature. Till that we have to pass the steam. Following observation we are getting from the least disc method. The thickness of the bad conductor small d, the radius of the bad conductor and metal disc small r, the mass of the slab that is least disc is equal to capital M, thickness of the metal disc is equal to h, steady temperature in the steam chamber theta 1, steady temperature in the slab theta 2. Normal conductivity of the bad conductor capital K, the rate of cooling of the slab at theta 2 is capital R. The specific heat capacity of the slab is equal to capital S. Area of cross section capital A. Here area of cross section is a circular, so therefore the A is equal to pi r squared. Based on the thermal conductivity equation, so here amount of heat conducted through the disc capital D per second, Q is equal to Ka into theta 1 minus theta 2 divided by small d. That is equation number 1. So here we know the A value, then we can substitute, then we can get the equation number 2. Next, the amount of heat loss per second by this slab, Q is equal to mass into specific heat capacity into rate of cooling. For Q is equal to MSR, that is equation number 3. At steady state condition, heat conducted through the bad conductor per second is equal to heat lost per second by the slab C. We can write the equation K pi r squared into theta 1 minus theta 2 divided by small d is equal to MSR. Therefore, K is equal to MSD capital R divided by pi r squared into theta 1 minus theta 2. That is equation number 6. So then K is a unit value watt meter power minus 1 Kelvin power minus 1. Least disc method, another subdivision is a experimental explanation. Here you are seeing that graph. Here x-axis time value is taken, y-axis temperature is taken. So if you note down the two values, we can get the curve. That curve we must draw the slope. That slope we have to mention A, B, C, whatever you are seeing in that graph, like that only. We know the slope formula AB by BC. So AB is belongs to temperature and BC is belongs to time. Then equation will get d theta by dt. So the temperature time graph is drawn and the rate of cooling d theta by dt at the steady temperature theta 2 is determined. So during the first part of the experiment, before the remove of the bad conductor and steam chamber, the top surface of the slab is converted by the bad conductor. So here value K is equal to MSD d theta by dt into R plus 2H divided by pi r squared into theta 1 minus theta 2 2r plus 2H. Therefore, thermal conductivity of the bad conductor is determined. So thank you students. Today we have discussed the 3 questions: expression for thermal conductivity and least disc method, experimental part and theoretical part. Thank you once again.